The horizontal boring, drilling, and milling machine, usually called the horizontal boring mill, is an adaptation of the principles of the horizontal milling machine for precision machining of larger types of workpieces. In machining large workpieces, such as this gearbox, it may be necessary to bring the workpiece to the tool, while some cuts will require the tool to be brought to the work. Either method is possible on the horizontal boring mill. The table on which the work is mounted moves in a horizontal plane. Some tools, such as this face mill, are bolted directly to the spindle sleeve for greater rigidity. The tool can be raised or lowered by moving the head up or down the column. However, the spindle sleeve cannot be extended horizontally. The work and the cutters can be brought into cutting position quickly by rapid traverse. When a cut such as this is taken, the head is clamped to the column and the saddle is locked to the bed. Here the work is fed to the cutter by automatic table feed. The table is moved away from the spindle or toward it by traversing the saddle along the bed of the machine. The spindle can be moved horizontally by a quick motion turnstile or by automatic feed. Cutting tools such as this end mill are mounted in the spindle. For this type of cut, the work is again moved to the tool. The spindle rotates and the work is fed into the cutter by automatic table feed. In boring operations, the work remains stationary and the tool is fed into it by advancing the spindle horizontally. Here, two cutters are mounted in a boring bar keyed to the spindle. The bar is driven by the spindle and supported by the backrest. The boring tools can be fed into the work by the spindle hand wheel or by automatic feed. Drilling is done in the same manner as boring, by advancing the spindle to feed the drill into the work. For safety, the machine is designed so that only one feed can be engaged at a time. There are several major units to the horizontal boring mill. They are maintained in accurate alignment to each other by the bed. The work is clamped to the table, which rests on the saddle. The saddle moves right or left along the bed. The table moves to or from the operator along the saddle. Thus, the saddle and the head unit provide movement in any direction on a horizontal plane. The column supports the head, which moves up or down. The backrest is used to support the boring bar. The spindle is part of the head. The head moves vertically, the spindle horizontally. The backrest block, which supports the boring bar, is connected to the head by a shaft and gears, so that when the head is raised or lowered, the block moves with it. Horizontal boring mills may vary in size and often in detail. However, the operating principles are the same. The machining of this gearbox is typical of the work performed on a boring mill. It is good practice to plan the sequence of operations before starting the job. The specific dimensions and the sequence of operations are found on the work drawing. The drawing indicates that the first operation is milling. This surface is to be edge milled. And this surface to be face milled. For an efficient production setup, a fixture is often used where like workpieces are to be machined. The fixture is identified by a number on the workprint. The number on the fixture corresponds to the number on the drawing. For safety and ease of handling, a chain fall is used to move large, heavy pieces. Always be sure that the lifter is attached securely. Before lowering the fixture onto the table, be sure that the contacting surfaces are free from dirt and chips. The tongue blocks on the bottom of the fixture fit the T-slots of the table. Center the fixture and lower it carefully to avoid nicking or scratching the table. When clamping a fixture or workpiece to the table, use clamping bolts which will give a full thread for the nut. A step block is used so that the clamp is level. Always use washers between the nuts and clamp. The bolts should be located as close to the work as possible, so that the piece is held firmly without placing undue strain on the T-slot. Draw the nut tight. The fixture must be clamped to the table evenly in at least 4 places. Use clamping bolts which will give full thread for the nut. Support the heel of the clamp at the same height as the toe. When tightening the nut, use a wrench of the correct size. Do not use an extension on the wrench. If the nuts are tightened too much, the threads may strip or the table may become distorted. With the fixture secured, the workpiece can be mounted. Lower it carefully into the fixture so that it rests against the adjustable stop. Many types of lifting devices are used to handle heavy workpieces. The lifter must be removed from the piece so that targets can be installed. The fixture has targets to aid in setting up the workpiece so that all surfaces and holes will clean up. Some targets are movable, others are permanent. Install the movable top target. Jack screws in the fixture are used to move the workpiece into position. The workpiece is first adjusted to the hole locating target. Turn the jack screws to bring the workpiece into a position where the targets completely cover all the cord holes. The slots in the target locate the center of the hole. Here the cord hole is off-center. By turning the jack screw, the workpiece is shifted until the holes are centered. The same procedure is followed to center the holes to the front target. Jack screws shift the workpiece vertically as well as horizontally. Watch the target while shifting the workpiece. See that the holes are centered. Check the edges of the front and top targets to be sure the surfaces will clean up. Adjusting the workpiece to one target will often throw it out of line with another. Before clamping the workpiece, check to see that the rear targets are still in line. When the workpiece is aligned with the front, rear, and top targets, it can be clamped to the fixture. In many cases, clamps are designed as a part of the fixture to save time in setting up the job. Use these special clamps when they are available. Clamping the work is important. A loose or poorly installed clamp is a hazard to the operator, the machine, and the work. Be sure all nuts are tight. With the workpiece clamped, scribe the outline of the target along the front face. This line indicates the finished surface. Also mark the work at the edge of the top target. Remove the top target. The front target must also be removed to make the cut. Measurement of the width of the flange shows that an end milling cutter 2 inches long will be needed to finish this surface. Measure the surface to be face milled. It is 15 inches wide, which will require 2 passes with a cutter approximately 8 inches in diameter. The end mill must be 2 inches long. It is 2 inches in diameter, which is an efficient size for the cut. A cutter large enough to make a 15-inch cut in one pass exceeds the recommended capacity for this size machine. An 8 3/4-inch cutter will mill the 15-inch surface efficiently in 2 passes. Always use a cloth when handling sharp-edged tools, such as this face mill. On a horizontal boring mill of this size, the larger cutters are mounted to the face of the spindle sleeve for greater rigidity. Before mounting the cutter, be sure the surface of the sleeve is free from chips or dirt. To be sure the back of the cutter is free from nicks or burrs, file it lightly. Be sure to clean the surface after filing. The hub of the cutter fits into the recess of the spindle sleeve. The cutter is held in place by 4 screws, which also help drive it. Draw all 4 of the screws up snug. Tighten opposite screws for final tightening. This will seat the cutter against the spindle sleeve. To install the end mill, run the spindle out by means of the quick motion turnstile. The hole in the face mill is large enough to allow the spindle to pass through it. Be sure that the taper of the spindle is clean. This spindle has a standard number 5 Morse tapered hole. Be sure the shank of the end mill is clean before mounting it. Notice the tang on the end mill. This tang must be lined up with the driving slots in the spindle. When the tang is in line, the shank can be slipped into the spindle taper. The end mill is secured by means of a tapered key, which fits into the forward slot of the spindle. Use a hammer and driver to set the key. Draw the spindle back into the sleeve, leaving the cutter in position for the first operation. Raise the binder handle to lock the spindle. Now it cannot be moved. The setup for milling with a fixture is now complete. In review, before starting the job, plan it carefully. Be sure to have a clear understanding of the operations required. Solid clamping is essential for accurate work. By the use of targets, the work can be located and positioned conveniently and quickly. Select cutters that will do the job efficiently. Be sure that the tool and the spindle taper are clean before mounting the cutters. Following these practices will aid in accurately setting up a job for face milling with a fixture.